Hello guys, welcome again to Mathematics Learning video with me, Miss Diana. Okay, in this video, we're gonna learn further how to do completing the square. This is another method to factorize or to transfer the quadratic expression into two linear expression. Let's try this completing the square. Actually, solving quadratics by completing the square give us more information, give us more complete information, such as in parabola, we can know the vertex. We can also know the axis of symmetry, and then the greatest and least value, and then the ranges of quadratic function. So for example, in here, I have a parabol of minus x squared minus 2x plus 3. Okay, what is the vertex? The vertex is in here. The vertex is the point in which the parabol changes its direction. So actually, whenever we read the parabol, we have to read the parabol from the left to the right. Okay, from the left to the right, we can see in here that the parabol goes upside or goes upward like this, and until this point, the parabol then changes the direction, which is goes downward like this. Okay, so in here, this is actually the point where the parabol changes its direction, so it's called the vertex. In here, the vertex is minus 1, comma 4. So the vertex for this quadratic equation is minus 1 comma 4. And then what is the axis of symmetry? Actually, it is easy after we know about the vertex. So the axis of symmetry is the x-coordinate of the vertex. So in here, the x-coordinate is minus 1. So the axis of symmetry here is x equals to minus 1. What does it mean, axis of symmetry? Actually, it tells us that the parabol like this has a symmetric characteristic. Whenever we like fold this paper or this parabol on its axis of symmetry, actually the left hand side of parabol will meet exactly to the right hand side of the parabol. So actually this is the axis of symmetry of this parabol. And then what is the greatest and least value? So in here, actually the parabol only has the greatest value. Why? Because this is the open downward parabol. So for the open downward parabol, it only has the greatest value, because this is the greatest or the highest part of the parabol, the highest point of the parabol. And then for the least value, actually only an open upward parabol whose only the least value. So if we have the smile parabol, actually it only has the least value. In this parabol, actually the greatest value is y equals to 4. Yeah, for the greatest value, actually we only get the value of y. So in here, y equals to 4. So the greatest value of this quadratic equation is y equals to 4. So now for the ranges of quadratic function, what is the ranges of quadratic function? The ranges of quadratic function here means all the set of value of y where the parabol sits on. So in here we can see that this parabol only sits on y equals to 4 downward. So the ranges of this quadratic equation, actually y less than or equal to 4, because the parabol only sits on from this value downward. Okay, that is the information that we can get after we have completed the square. Okay, now let's continue. Let's continue how to complete the square. The idea is like this. We want to express this expression ax squared plus bx plus c into the perfect squared like this, dx plus e squared like this. Okay, this is the main idea. Okay, now let's see how to express this into this. Okay, let's see this example. Example 1, solve this by completing the square, and after that find also the vertex, axis of symmetry, the greatest or the least value and the ranges of the function. Okay, let's see this together. Y equals 2x squared minus 6x minus 11. Okay, the first thing first, we need to change this y into 0. So x squared minus 6x minus 11 equals to 0. Okay, now the second things, we need to transfer this c value in here. The c value in here is minus 11 to the right side, or in other words, we need to add this both side with positive 11. Why we need to treat both sides in the same way? Because, okay, this is important thing that you have to pay attention, that if we treat something to the left side, we also have to treat the same thing to another side, to the right side. Why? Because we don't want to change the value, we only want to change the expression. So make sure if you treat something to the right side, you also treat the same thing on the left side. Okay, in here we have x squared minus 6x equals to 11. Okay, now the third way is we need to add both sides with half of b squared. In here, the b is minus 6, the half of b is minus 3, so we want to add this with minus 3 squared plus minus 3 squared. Okay, now after this, the fourth way, we want to change this expression into the perfect square. How to do this? Pay attention on this because this is the simplest and quickest way to transfer this into the perfect square like this. In here we have x squared, so we just need to put x in here, and in here we have minus 3 squared, we just need to put minus 3 here. Okay, and then in between we just put positive sign. Okay, this is the perfect square of this expression. Why we can just turn this into this? Because we have add this with half of b squared. It is the keyword. We need to add both sides with half of b squared. And after we add with this, actually it is easy to transfer this to the perfect square like this. And if you want to prove whether this expression is the same with this expression, actually it is easy. So in here we have x minus 3 squared, and then we just expanded x minus 3, x minus 3, and then start multiply down x squared minus 3x, and then x minus 3 minus 3x, and then minus 3 minus 3 positive 9, or in here actually minus 3 squared. So we have x squared minus 6x plus minus 3 squared. The same thing we have here. Okay, now it is proof that this perfect square is the same with this expression. Okay, now we continue here. It is 11 plus 9 here. Okay, in here we have x minus 3 squared, and this is 20. Now the last thing is we need to put this 20 to the left side again. So it is by subtracting both sides with minus 20. So it is x minus 3 squared minus 20 equals to 0. Or if you want to express this in just expression, you can erase this. So it is x minus 3 x squared minus 20. Okay, based on what we have got previously, that another expression of this quadratic expression is x minus 3 squared minus 20. Okay, now from this expression, actually we can find out the another information, which are the vertex, axis of symmetry, the greatest or the least value, and the ranges of the function. Okay, now I'm gonna explain to you first how to get this. Okay, now first thing first, please pay attention on the value of a here. So in this expression, a equals to 1, which is positive a. So if we have a positive, then we'll have the parabol like this, an open upward parabol or a smile parabol like this. And then pay attention on this part. So first thing first, we pay attention on x minus 3 squared. If we want to draw this this equation, x minus 3 squared, actually this equation show us that the parabol only offends the x-axis on one point on x-axis. So pay attention on this. If I try to solve this equals to 0, then I'll have x minus 3 equals to 0, then I'll have x equals to 3. So actually the parabol will offend only in one point on x, which is on x equals to 3. So in here is supposedly this is 3. So the parabol, this is the shape of the parabol. The parabol will sit on this. Okay, like this. The parabol will sit only one point, or will offend only at one point on x-axis, which is x equals to 3, like this. Actually, we don't have only this. We actually have another part, which is minus 20. What does it mean if we have another part, which is minus 20? It means that the parabol will go down, because this is minus. The minus means the parabol will go down as long as, or as far as 20 units. So for example, in here is y equals to 0. So the vertex will be here, minus 20. So if I shift the parabol will be like this. Okay, this is the parabol. So if it is plus 20, then actually the parabol will shift or will go upward. Okay, now in here we actually have y equals to x minus 3 squared until that, but in here we have x minus 3 squared minus 20. So this is the parabol that we have from this quadratic equation. Okay, the coordinate of the vertex here is 3, minus 20. So this is the coordinate of the vertex. Or if we want to get the vertex only by seeing on this expression, actually for the vertex. Okay, if you want to find the vertex, actually you just need to see on this number and this number. For example, if the vertex is a point a, b, then the standard form for this is y equals to x minus a squared positive b. So the vertex is 3, minus 20. Okay. Now for another thing, axis of symmetry. Axis of symmetry. For the axis of symmetry, we just need to get the x coordinate of the vertex, which is 3 here. So x equals to 3. This is the axis of symmetry. And then the other thing about the greatest or least value. Okay, but based on what we have here, actually this is an open upward parabol. So it means that this parabol only has the least value. Okay, whenever we are asked about the least value, actually we are asked about the value of y of the vertex. Okay, pay attention on this. Whenever you are asked about the value of the equation or the parabol, actually you are asked about the value of y. So in here, for the least value, because it only has the least value is y equals to minus 20. So the least value here, y equals to minus 20. Okay, now another thing about the last thing about ranges of the function. So for the ranges is all set of value of y where the parabol sits on. So in here, the parabol only sits on minus 20 upwards. So y more than or equal to minus 20. Okay, this is the further information that we can get from this expression. So actually, if we have the perfect squared expression of quadratic expression, actually we can get more information of the parabol. Okay, now please continue to see another example on the next video.